Alright, so we are going to work on radicals 4 today. For the warm-up, we have 2 times the square root of a4, b to the 5th. And number 2 is 32 times m, or the square root of m to the 5th. So if you go ahead and please pause your video if you have not finished those. Pause it, then go ahead and complete it and see if you and I have the same answers. Alright, so hopefully you've paused yours. I'm going to go ahead and work through this. Well, what I like to do is I say out here I have 2 times, and that's simplified, so I'm going to leave it alone right now. I highlighted it. And then I'm going to see I have a to the 4th and square root it. Well, the square root of a to the 4th is a squared. So that one's now simplified. B to the 5th, remember this is an exponent. So that's going to be the square root of b to the 4th times the square root of b. Square root of b to the 4th, we have to take half of our exponent, so it's b squared. That is simplified now, and the square root of b is simplified. I'm now going to go ahead and combine all my terms. 2 times a squared b squared times the square root of b. That's my final answer. On number 2, this one's pretty simple. 32 is on the outside, it's simplified. M to the 5th, remember that's an exponent, so we have to make it a positive exponent, so we subtract 1. We take 1 of the exponents away, so I just take 1 m away, which would leave me with m to the 4th. M to the 4th simplified. The square root of m to the 4th is m squared. I'm going to bring down my 32 and my square root of m. Sorry, I'm kind of highlighting these. So my final answer would be 32 times m squared times the square root of m. Hopefully you had those answers. Now, for today, our goal is I can apply the properties of radicals to multiply radicals. So we've been simplifying, and to be honest, we've already done some of the multiplication. We're seeing, like right here, how to multiply. B to the 4th times, or I'm sorry, the square root of b to the 4th times the square root of b is the square root of b to the 5th. So you're going to see how we're already kind of doing this. Alright, so our examples. If I take the square root of 6 and I times it by the square root of 6, because both of these are square roots, I can put them all under one square root. And then I just have 6 times 6, and the square root of 36 is 6. Well, so you should see there's a shortcut here. If I do the square root of a number times the square root of the same number, well, that's squaring a number. Because squaring something like x squared, that just means x times x. So if I do square root of a number times square root of a number, that's squaring it, and squaring undoes square root. You'd only be left with whatever one number was under there that was common. Here, I have a couple things happening. So I have the square root of 3x times 4 times the square root of x. Now, they wrote it this way, and that's fine. What they did was the 4 is on the outside, kind of like a coefficient, 4 times, so it's still on the outside. But on the inside of the square root, we have the square root of 3x, which is right there, and I have the square root of x. So I'm going to shade a different color. But now I'm going to have to simplify. 3x times x gives me, I'm going to go to this color, 3x squared. Well, I'm in the square root sign, so can I do anything? Well, I broke these two apart. I made the square root of 3 and x squared. And the square root of x squared is just x. So really I'd have 4 times x, which is 4x, times the square root of 3. Let's do a few examples here. Multiply the radicals and simplify the product. So number 1, square root of 3 times the square root of 3. I'm going to go through this one, but you should already get a little alarm on your head going, hey, wait a minute. I have a couple things common. But if you didn't notice, we could still say, okay, I'm going to do the square root, and it's 3 times 3. Square root, 3 times 3 is 9. Can I find the square root of 9? I can. The square root of 9 is just 3. Well, here was our shortcut. Since I did the square root of 3 and the square root of 3, they were the same. When I do that, the square root sign goes away, because this could technically be written as the square root of 3 squared. And when we have a square and a square root, they eliminate each other, and I only have the number that was being square rooted left. So if you look at number 2, the square root of 6 of, the square root of 6x times the square root of 6x. Both of these are the square roots. And they're both 6x. This will simplify to just, sorry, I'm not sure why that didn't really fill in. My final answer is just 6x. Because this would have came out if you did it. Square root of 36x squared. Square root of 36 is just 6, and the square root of x squared is just x. Multiply the radicals and simplify the products. Now, if you're following the rules, to be honest with you, it does not matter which order you do this. I could multiply these two together and get the square root of 48. And then I'm going to do exactly what we did the last 2 lessons and say, my factors of 48 are 1 to 48, 2 to 24, 4 and 12. Let's see, 6 times 8, and that's it. Okay? Go through my largest factors. Okay, is 48 a perfect square? No. Is 24 a perfect square? No. 12? No. Is 8? No. Is 6? No. 4 is a perfect square. So because of that, I would go the square root of 48. I'd make it into the square root of 4 times the square root of 12. Okay, so I kind of went a little ahead here. Alright, so if I had the square root of 48 and we broke it down to the square root of 4 times the square root of 2, you can see that's my original problem. So I really didn't do too much. What's better is I can simplify before I even multiply. So to do that, I'm just going to say, okay, I could continue doing this. And this would be the square root of 4 is my 2. Square root of 12, I'm going to break that square root of 4 times the square root of 3. And we're going to find out the square root of 4 is 2. I'm going to circle ones I have simplified. And 2 times 2 is 4 times the square root of 3. So when I did 12, the square root of 12 times the square root of 4, I'm going to get 4 times the square root of 3. Now, I'm going to erase all this, and I'm going to show you why. This is how I feel this is an easier setup. I just showed that longer way because it's longer and harder, But if you follow the rules of math, you can do it that way. Or I can simplify things before I start multiplying, just like with fractions. We like to simplify fractions before we work with them, so we're going to get larger numbers. I'm going to do just the square root of 12. Well, when you did 12, we got 1 and 12, 2 and 6, 3 and 4, and that's it. We looked for perfect squares. 4. So I would say the square root of 4 times the square root of 3. Square root of 4 times square root of 3 is the square root of 12. And the square root of 4 is 2. Okay? Square root of 3 is simplified. Square root of 2 is simplified. But now we also have the square root of 4. Square root of 4 is 2. I have all my simplified, so I'm going to go 2, which is this one, times this 2, times my square root of 3. Combine like terms, and I'd have 4 times the square root of 3. Either way would have worked. It's just this one happened to work out a little bit easier, less steps. When I go to number 2, I'm going to do the same thing. I'm going to go ahead and see I have 2 times 4. Well, I'm going to do that right away. 2 times 4 equals 8. That's my simplified answer there. I then have the square root of x, and I cannot simplify the square root of x. And I have the square root of x. I cannot simplify that. So I really have square root of x times square root of x. Now I'm trying to figure out what does that equal. Hopefully you're thinking right back to these two and say square root of x times square root of x. Well, I'm timesing by the same thing, so that squares them. This answer is just x. Remember, if you don't understand why, do the work. Square root of x times x is x squared. Square root of x squared is x. Okay? That's the work if you didn't understand what we just did. Okay? So my final answer is 8 times x is 8x. Multiply the radicals and simplify. We've already kind of discussed this. I have the square root of y, and I am squaring it. Remember, squaring undoes the square root. They cancel each other off. My final answer is just y. And I'm going to show you the work just because I want to make sure you understand this. But if I had the square root of y and I squared it, that means square root of y times square root of y, which is square root of y squared, and y squared, and find the square root of it, would just be y. But it's just a shortcut. We square things to undo the square roots. So the square root of 4x minus 3, and I've squared it. Squaring eliminates our square root. I'd be left with 4x minus 3. Multiply radical expressions. You can look at these examples. I'm going to go ahead and kind of move forward because I think it's easier when we actually do it. But all you're going to see is how they are distributing to get to their final answer, and then simplify. Biggest thing we're doing with radicals, boys and girls, is we're building off each day. We started with how we can multiply them. We've looked at how we can simplify them. Now we're going to look at how we can be multiplying all these together, large ones, and then we just have to simplify. It's the same concept as with fractions. Learn how to multiply them, but then always simplify. So I have the square root of 5. And I'm going to see I have this group, 4 times the square root of 5, 3 times the square root of 20, and 7 times the square root of 45. Okay? A couple of ideas what I could do. I could go through and see if I could simplify any of those first, or I could just multiply them across. Me personally, I'm just going to go ahead and multiply them across. So, square root of 5 times 4 times the square root of 5. Well, that's going to give me 4. That stayed on the outside. And my like terms are square root of 5 times square root of 5, which is square root of 25. Huge hint. Did anyone catch that we're going to be simplifying that? Square root of 5 times square root of 5 is the same number. Could just say a 5, so 4 times 5. But I'll show you how we'll simplify here. Okay, now I'm going to do square root of 5 times 3 times the square root of 20. Well, I'm still going to have the 3. Square root of 5 times square root of 20 is square root of 100. And my last term, square root of 5 times negative 7, still stays on the outside. And square root of 5 times 45, 25, square root of 225, I believe. Okay. And now we just go ahead and simplify as much as we can. We look to see, can we add or subtract anything that has like terms? Not yet. But square root of 25 is 5. So this one simplifies to 4 times 5, which is 20. Let's go to this color now. Square root of 100 is just 10. So I have 3 times 10, which is 30. And don't forget we're adding. And square root of 225, I believe, I'm going to pull up my calculator. I just want to make sure. It's 15. Now remember, this is a negative. 7 times 15 is 105. And if I look, I don't have any radicals. So I can solve this. 20 plus 30 is 50. Minus 105. 50 minus 105 is going to be negative 55. For some reason I'm not trusting myself. I don't know why. So, I don't get lazy. I double check myself. Okay. So that's how we solve that. Quite a bit of work, but it's because I show every single step. I don't get lazy on things. I show all my work and make sure I don't make mistakes. So when I don't know for sure, I double check myself. Okay, go ahead and see if you can do number 2. So pause your video, go ahead and work on it. I'm going to pause mine real quick, and then here in a second, you're just going to see the answer. Okay, so hopefully you got the answer, -1 minus the square root of 3. Real quick, you can kind of color code things, what I did. Biggest change was when I got to here, 2 minus 2 times square root of 3 plus square root of 3 minus square root of 9. I can simplify. Square root of 9 is going to be still minus 3. And when I have -2 times the square root of 3 plus square root of 3, because that square root of 3 is the same base, I can do -2 plus, this is essentially a 1 times square root of 3. So -2 plus that is going to give me just negative square root of 3. And 2 minus 3 was -1. Okay, I think this is your last one. Okay, 2 ways I would set this up. 4 times the square root of x squared. You can either go ahead and take this exponent and distribute it to both parts and say this is 4 squared times square root of x squared. In doing that, I'd simplify. 4 squared is 16 times square root of x times square root of x. That's going to do squaring. We'll undo the square root, so I'd have just x. and I'd have 16x. Or, if you felt more comfortable, you could have 4 times the square root of x times 4 times the square root of x. It's the same problem, but we have it twice. We squared it. And then I could multiply my like terms. 4 times 4 is 16. Square root of x times square root of x. Square root of x squared. And x squared squared. The square root of x squared is just x. So I know it's a little confusing when I can show it more than one way, but this is one reason I really do love math. Math has multiple ways to get to an answer. We typically show you one method, but there's multiple methods. You just have to make sure that you're abiding by the rules and follow an order of operations, and you can get there different methods, whatever you feel most comfortable with. So, I would like you to start on your Radicals Worksheet 4. If you have questions, please come and see me. We'll be finishing up with this. This is the last Radicals assignment we're going to do, and then we'll work on our review and test over this. So let's work on 1 through 28 for tomorrow.